In space exploration, we often hear about incredible launches, robotic landings, and breathtaking images of the cosmos. But behind every mission's success is something less flashy, yet equally vital: the reintegration of scientific instruments. In June 2025, NASA released epic behind-the-scenes footage showcasing the instrument reintegration process, a critical but rarely seen phase in mission preparation. This process ensures that a spacecraft's instruments, once serviced, upgraded, or tested, are properly reinstalled and ready to endure the extreme conditions of space. In this video, we'll explain what instrument reintegration is, why it matters, and how it fits into NASA's broader mission to explore the universe. Wrench emoji. What is instrument reintegration? Instrument reintegration is the process of reinstalling scientific tools and hardware, such as cameras, spectrometers, and communication modules, back into a spacecraft after they've been removed for maintenance, upgrades, or testing. This reintegration can happen before a spacecraft is launched, during mission upgrades while it's still on Earth, or even after a return mission, like samples brought back from Mars. NASA engineers must ensure that every piece is functioning perfectly, safely attached, and fully calibrated before the spacecraft is declared mission ready. Package emoji. Why do instruments need to be removed and reintegrated? There are several reasons NASA might temporarily remove instruments from a spacecraft. Testing and calibration. Instruments are rigorously tested under simulated space conditions to ensure performance. Upgrades. Newer, more advanced versions of instruments may replace older models. Maintenance or troubleshooting. If an instrument shows signs of malfunction during pre-launch checks, it may be removed and repaired. Integration into updated spacecraft designs. When missions evolve or hardware designs change, reintegration becomes necessary. In each case, reintegration ensures total system compatibility and mission success. Rocket emoji. What did NASA's 2025 footage show? The footage released in June 2025 comes from NASA's Jet Propulsion Laboratory, JPL, where engineers are preparing a next-generation deep space observatory. The video offers a rare look inside a clean room, where technicians in full-body suits delicately maneuver multi-million-dollar instruments into place. Key highlights from the video include: engineers aligning an ultra-sensitive imaging spectrometer with micron-level precision. Reintegration of a cryogenic cooling system used for thermal control in deep space. Final bolt-down procedures and vibration tests to ensure the instruments can survive launch forces. This kind of footage is both visually captivating and technically remarkable, showing how fragile science must be protected for violent launches and harsh environments. Satellite emoji. The importance of clean rooms and protocols. Reintegration occurs in ISO-certified clean rooms, which are ultra-controlled environments that protect instruments from dust, which can ruin optics; electrostatic discharge, which can fry delicate circuits; temperature or humidity shifts, which may alter measurements or cause condensation. NASA follows strict procedures including double-checking mechanical alignment, thermal balance testing, software cross-verification, redundant safety protocols. Even the tiniest misalignment or contamination could lead to mission failure, which is why reintegration is treated with the highest precision and care. Microscope emoji. Real-world examples of instrument reintegration. Several high-profile missions involved critical reintegration steps. James Webb Space Telescope, JWST. Before launch, its massive mirror and infrared sensors were detached for testing and reintegrated over several months. Perseverance rover, Mars 2020. NASA had to reintegrate its MOXIE oxygen generator and Sherlock spectrometer after system refinements. Europa Clipper, 2024 to 2025. Several science instruments were shipped separately and then carefully reintegrated into the spacecraft body at JPL. Each of these missions relied on precise reintegration to operate flawlessly millions of kilometers from Earth. Milky Way emoji. Why it matters to the public, you might ask. Why should anyone care about this behind-the-scenes process? Because without successful reintegration, we wouldn't receive high-resolution images of galaxies. We couldn't study Martian soil or detect signs of